So before I start page 3, I realized that I hit that 15-minute limit. So let me show you the end of page 2. So I did the fourth root. Reflecting over the x really means it's with the y. Horizontally shifting 2 units right. Right really means left when it's with the x. Vertical compression by a factor of 2/5, straight shooter. And then vertically shifting 6 units up, straight shooter. All right, let's focus on the back now, and I'm going to zoom in a little bit. Identify the domain, the range, an additional point, transformations of the functions. Okay, so I'm going to start with the vertex because that's something I know that they want. So my vertex, I just take the opposite of this and the y value, straight shooter. So I'm going to graph -4, -1. Now, normally it would go like this, but the problem is that there's a negative right there, which implies a reflection, okay? So we'll get to that in a second. So when we're going to reflect this, if we're going to keep that vertex the same, all we're doing is just putting it underneath. I don't need you to show me a vertical compression by a factor of 2/3. Just show me that it's flipped upside down, okay? So I've got the vertex, check. The domain is easier for me to see now because I'm a visual person. And I see that the x starts at -4 and then it goes this way, which means it's getting bigger. Positive infinity. And the range, it's my y. It starts at -1, but then it's going lower, which means it's less than, hence the reflection over the x-axis, but it's affecting the y. So that means that I start at -1 and I go to negative infinity. Oops, I'm sorry, I got it backwards. Always small to big. Negative infinity. Ah! So we want to be careful about that silly mistake. Close bracket. So domain, range, check. An additional point, I'll get there. I think that's a little bit more difficult. Let's talk about the transformations. For the 4, horizontal translation, not transformation, translation, 4 units right, because it's always the opposite. Vertical translation, 1 unit down. When it's with the y, it really means reflection over the x-axis. So if you look, it looks like it's flipped upside down. And then the 2/3 represents a vertical compression by a factor of 2/3. Let me tell you right now, you write this down, I don't know what that means. Horizontal translation, 4 units right. Vertical translation, 1 unit down. Reflection over the x-axis, vertical compression by a factor of 2/3. Okay. The additional point is where I'm going to plug in any value. So in a sense, I'm making a table. I obviously can't pick -4, -1. But then I can pick any other point. Now I'm trying to think of what would be a perfect square root. So I think of like the square root of 1, the square root of 4, the square root of 9. So I know what value could give me a 1. If that x was -3, then that could give me 1. If the x value was a 0, that could give me a 4. If the x value is a 5, 5 plus 4 can give me 9. Okay? I actually think I'm going to do the 9 because when I take the square root of 9, it's 3, and there's a 3 in the denominator. Okay? So I'm going to pick this one. I don't like those two. I could use them, by the way, so I'll still give that to you. So 5 plus 4 is 9. The square root of 9 is 3. So let me show some work. So I'm going to go -2/3 times 3 minus 1. 3 on top, 3 on bottom, bye-bye. -2 minus 1 is -3. I love whole numbers. I would like to show you if it was the 0. 0 plus 4 is 4. The square root of 4 is 2. So I'm going -2/3 times 2 minus 1. That's -4/3 minus 1. Your calculator can tell you an answer, but I'm hoping some of you know that 4/3 is the same as -1 1/3. Minus 1 is -2 1/3. If I was to do the 1, then I would do -3. -3 plus 4 is 1. The square root of 1 is 1. Times 2/3 is -2/3 minus 1 is -1 2/3. So I actually feel like the 0 one's the easiest. But just give me 1 point and show me some work that you didn't just make it up or copy your friends. All right. Finding the inverse. Remember, step 1, switch the x and the y. There's different ways to approach this. I think the easiest way for me is to just manipulate the equations a little bit. So I'm going to multiply both sides by y. I get xy equals y plus 3. Now, since I'm trying to get the y by itself and they're on different sides, if I move this over here, at least they're on the same side. Now, I'm not subtracting y from a multiplying x. That doesn't make sense. So I'm just going to write them separately. But now I see they both have a y, so I factor it out. I'm almost done with solving for y. I just have to get rid of this. So I divide by x minus 1. Boom, the y is by itself. Oh, but don't write f inverse, because that's a g. So g inverse x equals 3 over x minus 1. Okay? This one is actually going to be a pretty big workout, so I'm going to use separate paper so that I can do it all on one piece. So let me write the function. F of x equals negative 2 rad x plus 9 minus 1. First thing I do, switch the x and the y. I need to get rid of what's on the outside first. I always divide last. So I'm going to add 1 first. I'm going to divide by negative 2. And honestly, I'm going to have 2 fractions here. So I think I might leave it for now just like that until I'm not happy, and then I might change it. I'm not sure yet, honestly. I'm not sure what I want to do. I could have written this as negative 1/2 x minus 1/2. So I just want you to see that. But for right now, that just looks crazier to me, so I'm ignoring it. And now what I'm going to do is, because the radical is isolated, I'm going to square both sides. I like the right side. I can handle that. I can even handle the bottom. Negative 2 squared is 4. And then for the top, what I'm really doing is the quantity x plus 1 squared. I box that out, and I get x squared plus 2x plus 1. If I wouldn't have done it like this, and I would have left it like this, I would have had to box this out, and that seems super uncomfortable to me. But whatever, you're going to get the same answer, so I guess I'll show it. If I was going to box out, I could go negative 1/2 x minus 1/2, negative 1/2 x minus 1/2, and then I'll show you how it's equivalent over here. Now I feel like I want to divide. 1/4 x squared. 2 over 4 is the same as 1/2, and then 1 over 4 is 1/4. Let me show you over here how I could have done that. A negative 1/2 times a negative 1/2 is a positive 1/4 x squared. 1/4 x squared, 1/4 x squared. Negative 1/2 times negative 1/2 is positive 1/4 x. And this is the same thing. And if I had a fourth plus a fourth, that's 2/4, which is 1/2. And then when I go 1/2, oops, I messed up on that. When I go 1/2 times 1/2, that's 1/4. And so you see, you get the same thing, whatever works for you. Let me rewrite this so it looks a little bit less ugly. Now I have one more step. I just need to subtract 9. And I end up with, and it started with f of x, f inverse of x equals 1/4 x squared plus 1/2 x. And 1/4 minus 9, you can either write it as negative 8 3/4. You can rewrite it, and I guess because you're, let's see, what was your calculator going to say? 0.25, so you go 1/4 minus 9. I'll take negative 875. That's fine. Okay, whatever. Whatever you want is fine with me. If you want to go like this, you're actually cooler. 1/36, 4, so negative 35 over 4. I actually like that one the best, so I'm going to stick with that. And that's my inverse. I'm obviously not going to have you graph it, okay? All right. Let's go to the next one. Find the inverse. Switch the x and the y. Okay. Now what I'm going to do is subtract 6. It's a pretty similar problem. Okay. Now I divide by 3. I get x minus 6 over 3 equals the 5th root of x minus 1. Okay. And now what I'm going to do, oh, let's say the 5th root. Okay. So now what I'm going to do is I'm going to take it to the 5th power. You know what? Let's make the cube root. Let's change that to cube root. I don't like that that's done like that, so we're going to make that the cube root. Because otherwise, taking it to the 5th is ridiculous. So then I'd be left with x minus 6 cubed over 27 equals x minus 1. Oops, y minus 1. I'm doing awesome on this problem. Okay. Now what I'm going to have to do is box out x minus 6 cubed. So if I'm going to box out x minus 6 cubed, what I'm going to do is I'm going x minus 6 times x minus 6, which is x squared minus 12x plus 36. You'll box that out yourself. And then I multiply that by x minus 6. And I get x cubed, let's see, minus 6x, minus 18x squared. Let's see. Let me finish this up. I'm trying to do it in my head. Plus 108x, and then minus 216. Okay? So I get that. Let me figure out what I did with my paper. Okay? And that's what's on top. So let me see if I can. So I just did this, gave me that. So I'm going to move this work, and I'm going to go down here. So now it's this, all divided by 27 equals y minus 1. So that's the same thing as 1 over 27th x cubed minus 18 over 27, divide by 9, divide by 9. Divide by 9, divide by 9. Oh, well it's 12/3, so that's 4. And then 27 goes into 216. I'm not as good at that one, so let me do that one in the calculator. 8. Perfect. Minus 8 equals y minus 1. Move this up a little bit. Add 1. And I end up with, since it started as f inverse, or f of x, it's f inverse equals 1 over 27x cubed minus 2/3 x squared plus 4x minus 7. Now, I will tell you, so let me go back to this. These two are crazy. You either get this crazy or this crazy. You won't get both crazies, okay? But you probably will get one of them. All right, let's go to the next one. When you look at the next one, find the inverse. So I'm going to switch the x and the y. Subtract 10. Don't forget the negative. I'm going to multiply both sides by 3. Divide by negative 5. And I end up with f inverse of x equals negative 3/5 x plus 6. And by the way, if I have a lot of time on my hands, I could find the inverse of this and see if it's that. Or when I fake graph it, let's see if it works out. Okay. You'll have a graph on your test, I'm pretty sure. Up 10, down 5, right 3, f of x. Up 6, down 3, right 5. Something doesn't feel right. So let me pause it real quick and check my work. Something doesn't feel right. So I think I figured out why it doesn't feel right, and part of the reason it doesn't feel right is because I faked it a little bit too much. So that's down 5, right 3. This should be down, up 6, down 3, right 5. So it looks more like that. And that's f inverse of x, and then dash, 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 my reflection line. I guess I wanted a table with at least 3 points for both functions. This is a good workout. So if I'm going to do that, let me do that right here. So for f of x equals 10 minus 5 thirds x. What I'm going to focus on when I'm doing a table is what the denominator is, so that